In this video, we're gonna solve the following equation. So we see that this equation is defined by some logarithmic values. So it's the natural log of x plus the square root of the natural log of x minus 2. One of the ways that we can do to solve this one using algebra is to make sure that we have these values defined. So we can have this first value of the natural log defined if we have x is bigger than 0. And from here we get two conditions. First, the natural log to be defined, we need to have x bigger than 0. And to have this one inside of the square root, we need to have the natural log of x greater or equal than 0. So these conditions would let us find the values of x that will make this inequality having a sense, or to have a sense. So let's graph the natural log of x. Okay, quickly we know the graph. Okay, so this value is 1. Okay, we look and it's defined on the 0 plus infinity. So we are looking for the values of x bigger than 0. That means we are here. Also, we have this condition. The natural log of x is greater or equal than 0. So that means x is bigger than 1. So because the natural log of x is bigger than 0, when we have ln of x is bigger than natural log of 1, because the natural log of 1 is 0. So this gives us that x is in this interval. Okay, so this is our interval to have this one a meaning. Okay, so under these conditions, that means under this one condition, finally, that we get that x is in this interval, we let another variable, or we change the variable here to make this equation simple enough to solve. So let's choose, okay, we're gonna take care of the square root. We don't want to solve under the square root. So let y equals the natural log of the square root. The square root of the natural log. So this condition gives us what? So if x is in 1 plus infinity, that means the natural log is bigger than 0. That means y is greater or equal than 0. So this is good because we need to see this change gives us these values. Okay, so now if we have this condition, so we can take the square root because these values defined is positive. So here we take the square root of y squared is ln of x. Okay, and this helps us here. Okay, so now we can transform this equation under this condition to this equation. So y squared plus y minus 2 equals 0, with y is bigger than 0. So now we know how to solve this one. Okay, we can split these two onto minus 1 and minus 1. So we have minus 1 plus y minus 1 equals 0. So here we can factor out as y minus 1 times y plus 1 plus y minus 1 equals 0. So we have this y minus 1 as a factor, and we finally have this equation. This one has two solutions. Either y is 1 or y is minus 2. This one to be rejected because of this condition. This one to be accepted. So this one is a solution. So once we have this solution, let's go and plug it back. Let's see here. So we're gonna solve. Now we have to solve this system here. So now we have y equals 1 equals ln of x squared. Okay, here squaring both sides, we get the natural log of x is 1. And when can this one happen? When we have e. the base for the natural log. So that means x, that means this one is equal to e. That means x is e. Okay, another condition that we need to check is x equals e in this domain that we have. Yes, yes, it is. In this domain. So, and this means that it's a solution. So a solution of this system is e. We can check it. The natural log of e is 1 plus the square root of this one is 1. So 1 plus 1 minus 2 is 0. So that means e is a solution. It's the only solution. That means it's the solution of this system. Okay? These steps are very fundamental to be rigorous. We can do another thing that we need to learn. We can, this one here, this equation can be graphed in following manner. We can look for ln of x and 2 minus the square root of the natural log of x and ln of x. So we let this one equals f of x, this one g of x, and we graph them and see where they intersect. They will do it in e. Okay, so but this is not our goal. Our goal is to solve this equation algebraically, and this is the solution. Remember this one. This is helpful too. Okay, thank you very much.